Cerspense. He is an incredible visual artist and I think one of the leading creative technologists in real-time AI. His specialty is the laser, and you can see his installation back there. He creates incredible live visuals using a combination of StreamDiffusion and Animate Diff and other tools like Touch Designer, Comfy UI, and Notch. And his like signature look is really original and mesmerizing to look at. So I think his creative vision is quite inspiring. And so please help me welcome Cerspense.
Yeah, so my name is Spencer, and I'm going to kind of show you this project I've been working on that's the installation that's over in the corner over there. So I'm going to give you a bit of background and then kind of walk through the system, and then we can do some questions. So first of all, I've always been super inspired by music visually, and I always wanted to kind of use different digital tools to kind of recreate my internal visions of music as I listen to it. And I started off doing lots of stuff with 3D and pre-rendered motion graphics using Cinema 4D and other tools, and then really latched into real-time tools as a way to explore and kind of create like visual synthesizer systems that I can perform in real time and create visuals on the fly. And that kind of led me to doing lots of jobs in live events where I'm doing real-time effects with programs like Notch, Touch Designer, Unreal Engine, and also doing stuff with Cinema 4D. And also got into tools like Max MSP and also working in Python. Also worked a lot in virtual production and done lots of custom model training, like this one called Zeroscope, which I trained a few years ago. And then after that, went and worked at Runway for a year. And then now I'm just freelancing, kind of making art and doing fun different gigs, mostly in live events and the AI space. And now I'll kind of show you this system here. So I'm remoting into the computer that's actually running the installation right now. So, oh, that looks really glitchy. Let's see here. Yeah, we'll just do a window. Why is it so glitchy? Let's see here. Okay, so I'm just going to kind of show you how this whole setup works. So it's all designed in Touch Designer. And it all starts pretty much with this noise texture here. So here, let me make this full screen again. I think it's better. So I start with a noise that's coming in, and then I essentially am going to feed that into StreamDiffusion. So I have a feedback loop that allows me to generate an image from this noise and then iteratively pass that through the system, so render a new image based on that one, and then take that image and then put it back into the beginning of the process and continuously diffuse over it. And this allows me to get a really interesting, somewhat temporally consistent result that allows me to kind of explore these kind of latent spaces in real time. And so this is what the kind of raw output out of StreamDiffusion looks like. And what I'm able to do with this is actually like steer the direction of it and kind of like zoom in and out and kind of control the amount of feedback. And this gives me like a really, it kind of is like Deforum in a way where you can explore this feedback loop in real time and have like a lot of fun with it. And I've been really enjoying this kind of feedback interface. So the way that it works is that frame is generated, and then it goes over to the NVIDIA upscaler here. So this is a real-time upscaler that's taking it 2x. So it's starting off at 576 by 448. So it's a little bit bigger than 512 by 512. Sorry, and this is to get it a little bit to a wider aspect ratio. Also, this is currently using SDXL. So this is kind of StreamTD version 3 with SDXL and IP adapter. So I'm able to prompt with images. I could also use ControlNet. I'm not using it right now. And yeah, being able to use SDXL is like a huge, huge improvement over kind of the previous setup. So after the frame is generated and upscaled, it goes through like a sharpening phase, And then I'm doing this effect called dilate, which basically takes the white pixels and it moves them, it expands them out a little bit. And this allows the visuals to kind of continuously evolve and breathe, even if you aren't explicitly zooming into it. And then I have some color controls that when you're doing it in this feedback loop, you can use these color controls to kind of dial it back or kind of like make it less saturated or more saturated each iteration through the feedback loop. So it gives you control over kind of the direction that it's going in as it feeds back. And then finally it goes through this little transformation step here, which actually allows you to like steer through it. And so that's what's being, that's what's allowing this to actually move around in space like this. So by clicking and steering with my mouse, I can actually drive the generation of this and kind of fly through these different latent spaces. And I essentially designed this to be used as a visual instrument during live performances, so I can improvise visuals during musical performances. And I don't have to worry about creating a bunch of content and like managing it and like having all these things preset. I can just generate anything I want on the fly. And anyone else that wants to collaborate can like walk up and start prompting stuff and trying things, and it's just like tons of fun. So that's the basic StreamDiffusion side of it. I'm mixing between the noise and the feedback output, so it kind of allows me to control how much feedback there is over here with this cross. And I also do a little bit of noise injection, so I kind of am just compositing a little bit of noise into the render here before it goes in to kind of add a little bit more motion and creativity, and also helps enhance the detail as well. There's lots of little tricks like that in StreamDiffusion you kind of figure out in real time as you're just feeding things in and seeing how they work. And noise is definitely a very particular thing when you're feeding it into these AI systems. Here I have this as a little setup just to calibrate the entire thing with the laser mapping. So if I change it to 1 now, it goes to the grid. And so this allows me to kind of map the lasers and the projection like that. Turn it back down. So then it kind of goes to a few different setups over here. So up above here, I'm doing just some color correction on the output to kind of output it to the projectors. And then down here, actually, I'll go down to the bottom first to show this. So here is where it's actually being prepped for laser tracing. So the video comes in here, and then I'm taking a threshold of the video. So I'm basically cutting off a lot of the darks and basically a lot of the dark values and getting this kind of hard edge. And the reason I do this is because lasers, it's a physical mirror that's moving and trying to trace these points that you're giving it in real time. And it has physical limitations. It's not like a CRT that can move extremely fast, like an electron beam. It is a physical mirror that moves like at the rates of like audio, essentially. So it's like up to 60,000 hertz or like 40,000 hertz. And because of that, it can only hit about 500 points per second. And so you have to really feed in simple geometry in order to optimize that laser path that is generated in the end. And so I came up with a few different ways to kind of simplify the geometry. It starts with thresholding, and then I do some compositing tricks where I kind of like make it bigger and then composite it over itself to subtract it from itself to kind of simplify the geometry. And I have a few different methods here for doing that, all kind of designed in Touch Designer. And so I can kind of switch between these methods on the fly using my MIDI controller and kind of find the one that works best in that moment for that particular visual that's up on screen. And then once this is kind of where I can switch and select which one I'm using, and then it gets sent over Spout to another instance of Touch Designer because the laser tracing one is too heavy to run inside this same project. So this is what that looks like. Oh, it's on a different screen. Let's go here, yeah. So inside this other Touch Designer project, it's being sent over Spout, so it's a shared GPU buffer. So as long as you're using a computer where the two programs are sharing the same graphics card, you can send this lossless texture across them with 0 latency and full quality. And so that's how I'm sending data, video data between these processes. But it comes in here, and then it passes into this little comp that I made in Touch Designer here. So this will take it and actually do the trace. So We do another threshold here to kind of clean it up a little bit more, and then this trace sop is kind of where the rubber meets the road. So the actual pixels are traced into paths that are vectors in real time here. It's still pretty intensive and runs on the CPU, so it gets a bit heavy, and it's single-threaded, so that's why I keep it on its own process. So that if it gets bogged down with way too much detail to trace and it starts freaking out, it doesn't drag down the rest of the performance system. And from there actually is a little bit more resampling and optimization of those paths to make it a little bit more digestible for the laser. And then I have this kind of laser effects system. So it'll take kind of that full path, and it'll allow me to kind of choose like how much of it actually gets traced by the laser. So this is kind of tracing all of the available geometry with the laser. And then these other presets I can select from, they trace like smaller subsections of it. And with a laser, when you trace like smaller and smaller pieces of it, and the laser has more time to cover that geometry, it results in a much, much brighter beam and a much brighter image. Because the less you're moving the laser, the more it's staying in the same place, and it's much, much brighter when you actually see it. And so if you just give it like a single point, a single dot, then it's just like a death ray, like a single point laser that's as bright as possible. And the more you spread out that geometry and trace more and more, the less bright it gets. And so that's why I've kind of created a lot of different presets here to kind of choose between these different configurations for whatever is working best with the particular graphic. And then from there, this is how I'm applying color. It's basically using UV mapping with SOPs. And then over here, I had to kind of figure out a way to do the laser mapping side, because I will do, with projection mapping, there's already existing tools in Touch Designer that'll do that, called Canton Mapper. And that system works for pixels, and it'll only output pixels, but not laser signals, because laser signals are vectorized pieces of geometry. So they're actual like paths that are, yeah, geometry. It's not just pixels. So to kind of get around this, I found this mesh that's actually used inside of Canton Mapper. So if I open up Canton Mapper here, you can see this is kind of like the mesh. It's a little bit skewed for different reasons because of the aspect ratio of a laser. But this essentially lets me projection map the laser setup. And so right now, this doesn't directly output to laser, but then I found this mesh inside of it that's used internally, and I extract it. I kind of select it and extract it here, and then I use this creep SOP, which will take the laser geometry, and it'll map it onto this plane. And so I've essentially hijacked kind of the Canton Mapper projection mapping system and repurposed it for lasers using this kind of trick. Also here, I'm using this laser preview that kind of comes as a example in Touch Designer, and I use that later on in the compositing process. And yeah, I have two different lasers, so this is for one laser, which we were just looking at, and then the second laser, and we take both of the previews and we send them back out as spout, so I can pick it up in the original process again. So, oh wait. Let's move this back in the center. There we go. So then when I pick that texture up again, over here, we have kind of both of our lasers. It's on black, so it's kind of hard to see, but we have a visualization of both of the lasers here. And I take that and kind of add some feedback effects to it to make it look as if almost like it's burning into the screen, so kind of like a smoky effect like this. And then I composite that back on top of the visuals to kind of create this laser trace kind of smoky effect. So the visuals are tracing the content, and then they're also providing content themselves, like they're interacting with the content as well. So I kind of like to have that kind of like loop in between. And then over here, it goes out to the projectors, and that's kind of the entire setup. So from here, I kind of have like a user interface that allows me to kind of change the transform in the feedback loop, and this allows me to kind of like zoom in and zoom out, and we can prompt it. So we can prompt for anything. Like I'll just do like smiley face, and yeah, we get smiley faces. And we also have IP adapter now, which is extremely exciting. And this is also running in SDXL in real time, which is also insanely exciting and way better than SD Turbo. So we can crank up the IP adapter. We can change which image I'm using. I'm gonna overwrite this now, but these are just image references that I've kind of like made from like a board, essentially. You can see as soon as we change it, like we're kind of adopting this style along with our prompt, which is super cool. It's tons of fun to play with this, especially during a music performance. So yeah, it's pretty fantastic. And yeah, I'm also able to change like things like the seed travel speed, so it's kind of very gradually moving between seeds in real time to kind of keep the motion going. I'm doing like black level and other color correction in the feedback loop to kind of keep it where I want brightness-wise. I try to keep everything on a black background and more minimal because then the lasers are more visible with the beams. You really need to like provide enough negative space for that to work, and so I've kind of designed the system in order to produce things on black so that it looks that way. And then, yeah, so this feedback safe toggle is kind of the thing that allows for the feedback to work. And without it on, it'll just kind of go crazy. It'll start getting into like this jittery kind of behavior that kind of breaks the feedback loop. And so something that Lyle helped develop to kind of make this possible is this feedback safe toggle that allows us to only generate a frame whenever we know that there's a fresh one that comes in through the feedback system. And this allows for this smooth evolution of and kind of temporally consistent exploration in kind of this AI space, which is super fun. Yeah, I'd say that's most of what I want to show. I can also show some of the shows that we've done with it. So this is kind of like an earlier version of this system where I wasn't using lasers yet, and it was mostly made in animate diff. This is kind of an earlier version of it. And then, oh, this doesn't work. Then this is kind of another version where I'm tracing using pre-processed depth. So I'm using the depth map to determine where to trace. And then I started integrating lasers with it. And this is a renegade tunnel show that I've done with my friends this is kind of the older version of StreamDiffusion. And then this is one of the more recent ones using the IP adapter and everything. So yeah, I think I'll open up the rest to questions. If anyone has any questions about the system or anything else, yeah, that's it.